Hello, hello. Welcome back. We are covering 1.4 Introduction to Identities. All right, take notes. Make sure you are taking notes. 1.4 Introduction to Identities. So identities are pretty much equations, things that are the equivalent for all x's. Okay, so we're going to go over several of them. The first set here are the reciprocal identities. Okay, and so the reciprocal identities, we've already kind of touched on that a little bit because we noticed that, sine theta and cosecant theta are reciprocals of each other. Cosine theta and secant theta are reciprocals of each other, and tangent and cotangent are reciprocals of each other. So here we just kind of say it more formally. Okay, so we know that sine theta is the reciprocal of cosecant, and we know that cosecant is the reciprocal of sine. So we noticed that when we looked at the first definition of trig functions, where we look at the trig functions defined in terms of x, y, and r. Okay, so cosine theta, we also notice that that one is the reciprocal of secant theta, and that secant theta is the reciprocal of cosine. Okay, so they're the reciprocals of each other. And then same thing with tangent theta. Okay, so tangent is the reciprocal of cotangent, and cotangent is the reciprocal of tangent. Okay, so we have these here. Really, there's no memorizing here. I think you're already familiar with the fact that sine and cosecant are reciprocals of each other. Cosine and secant, tangent and cotangent. So, so we write this down, but it's not like you have to memorize 6 new things. Okay, so let's take a look at some examples here. If sine theta equals negative 2/3, find cosecant. Okay, so we know that cosecant is the reciprocal of sine theta, right? Is the reciprocal of sine theta. So if I take the reciprocal of negative 2/3, then I get negative 3/2. Okay? Okay, so let's take a look at this one. If secant theta equals 7/3, let's go ahead and find cosine theta. We know that cosine theta is the reciprocal of secant, so let's take the reciprocal of 7/3, and we get 3/7. Okay, and if cotangent theta equals negative 7/5, find tangent theta. And same thing with this one here. Tangent theta is the reciprocal of cotangent theta. Therefore, the reciprocal of negative 7/5 will be negative 5/7. Okay. All right. So pretty straightforward there with the reciprocal identities. Okay, let's take a look at the ratio identities. Ratio identities. Okay, so we have 2 of them, one for tangent and one for cotangent. So it turns out that tangent is sine theta over cosine theta. That's kind of an important thing to know. And that cotangent theta equals cosine theta over sine theta, which makes sense since cotangent is the reciprocal of tangent. Therefore, we take the reciprocal of sine over cosine, which will be cosine over sine. Okay. Before we do some examples with these two ratio identities, let's see why. All right, so we knew in that first definition of trig functions that sine is y over r, and we know that cosine theta is x over r, right? And we also know that tangent theta is y over x. Okay, so let's take a look at this. Okay, so if I take sine theta over cosine theta, let's see what we get. Sine theta is y over r, and cosine theta is x over r, right? And one way to look at this is as division, y over r divided by x over r, right? This is y over r divided by x over r. And when we divide, we turn it into multiplication by the reciprocal. And here we can cross cancel the r's. And we get y over x. But y over x, we know, is tangent. Okay, so we do see here that sine theta does equal tangent theta. Okay, and if that's the case, then we know that cotangent is the reciprocal, so cotangent is cosine over sine. Okay. All right, let's take a look at some examples here. All right, so if sine theta equals negative 3 over 5, and cosine theta equals 4 over 5, let's find tangent theta and cotangent theta. All right, so we know tangent theta is sine over cosine. So that's going to be negative 3/5 over 4/5. And if you want to treat this like division, then that's like saying negative 3/5 divided by 4/5. And you can change this to multiplication by the reciprocal. And those cancel out. So we get negative 3 over 4. Okay? So, tangent theta equals negative 3 over 4. Therefore, cotangent theta equals negative 4 over 3. Okay, so those are pretty straightforward as well. Let's take a look at the squaring trig functions, the squaring of them. Squaring of trig functions. So we're bringing this up here so that you're familiar with the notation. Okay, so when we square something, like here, before we begin. So when we square 5 squared, right? This means 5 times 5, repeated multiplication, right? And that's just 25. Okay, so we still use the exponent 2 when we want to square a trig function. So here in trig, if I want to do sine theta squared, we don't really write it like this. We actually write it like this. Okay? And this means the same thing. Sine theta times sine theta. Okay? All right, so And that goes for all the different trig functions. I'm not going to write that notation for all of them. Okay, but this is going to be the one that we use. Okay, so we use this notation. Okay. All right, so let's take a look at an example here. So if sine theta equals 3 over 5, then sine squared theta is going to be 3 over 5 squared. And if we square that, we get 9 over 25. Okay? Same thing if we have cosine. Same sort of notation here. If cosine theta equals negative 1/2, then, and it goes for all the exponents, not just squaring, but even with cube, if we raise it to the third power, not sine, we're doing cosine. When we raise it to the third power, we still put the exponent right there. Okay, so this would mean negative 1/2 to the third power, which would give us negative 1 over 8. Okay? All right. Okay, so that is it for this first part. So make sure you stay tuned for the second part, because the second part deals with another set of identities called the Pythagorean identities, and those are very important, especially for the next section. Okay, so make sure you watch part 2. Now that we know what this notation means, we can talk about the Pythagorean identities. Okay, I will see you in the next one, or you can go ahead and start on the homework right now and then come back and watch the second part.